What's up guys, this is Ronnie. Welcome back to our channel Total Technology. This is tutorial 14 and today's topic will be Numpy fancy indexing. So we have discussed on different sort of indexing, for example using like integer index and slicing. We did multiple examples in the initial part, but this is going to be a brand new tutorial, and in this tutorial I'll be going to talk about fancy indexing. So this is going to be like kind of again hands-on driven approach, so just try to understand the theory first, then I will gradually explain the actual implementation using some lines of code. Okay, so what is fancy indexing? So Numpy offers more indexing facilities than regular Python sequences. In addition to indexing by integer and slices, means in normal Python array or normal list, we can like do index using integer or like slice. Okay, and in Numpy there is some additional thing called fancy indexing. And what is that? Numpy array indexed by array of list of integer is known as fancy indexing. Means you'll be going to index your array based on some list, and inside the list you'll be going to pass multiple integers. So for example, let me explain this thing using some sort of code. Okay, so import Numpy as np. Okay, and then let me just highlight this as example 1. So let's create one array, np dot array or arrange. Okay, so let's create 12 into, or let's say 5. I'm just thinking, let's create 6. Okay, like this. So this is what is going to happen. So it will start from 0 to 6, all the square number will be there. Okay, so if I print this thing, see I got this thing 0 1 2. Okay, sorry, actually I did a mistake. So I was trying to do this thing actually. Okay, fine. So I got starting from 0 to 5. Okay, so 0 1 2 3, and see all these are whole square number until 0 to 6. Okay, so 6 will be excluded, we all know. So now what I'll do, I'll try to index this thing using normal Python method. So if I put this thing, I'll get 1, and if I do some sort of slicing to 3, okay, so it will start from 1 means 1, then 2 3 until this. So actually I will get 1 and 4. Okay, so see I'll get 1 and 4. So this is actually normal way of doing slicing, sorry, normal indexing using slice and using index. Now there is a different way of doing it. So as per our definition, if you see, Numpy array indexed by arrays or list of integer is known as fancy indexing. So what is that actually? So let's put a, and inside that this is something like that, and inside that there will be a list, and inside the list you'll be going to put some integer. For example, if I put 1, okay, and if I put 4, so 1 means this one and 4 means 0 1 2 3 4. So this is going to be like 1 and 16. See I got 1 and 16. Why 1? 1 is from this and 4 means this, and this will be inside this thing. So see, I also got the fancy index, got the same element back from here, but here I actually applied to different things. So actually this is kind of a list or array, and inside the array I passed the different integers, and based on that I got our this thing. So this sort of indexing is known as fancy indexing. Means we have actually passed a list of arrays, and inside the we have passed a list of integer or array of integers, and that is going to be actually get the different items from the actual array. So 1 means this one, 4 means this one. So this is our first example. So what I'll do, I will just cut this thing here like this. So let me just take this thing and I'll put this thing here. So this will be easily you guys will be able to understand this thing easily. Okay, so actually I did this thing here for single dimension. Okay, so in the next tutorial, means in the next exercise, I'll be going to do it for second dimension, like 2D indexing. Okay, so let's just remove everything. Okay, example 1, so example 2. So again, let me create another array, np dot. So okay, so you all know that two-dimensional array means every element inside a two-dimensional array itself will be a 2D array. 2D array means every element inside a 2D array will be a 1D array. So this is our one-dimensional array. So what I'll do, I'll just create like a okay, like this. Okay, like this. Data type not understood. Okay, what is this? This is saying data. Okay, sorry. So this is going to be this. Okay, and let's print this thing. See, I got the 2D array back. Okay, so see, if every element in this 2D array is a 1D array. For example, this is 1D array, this is 1D array, and this is also an 1D array. Okay, right? So now what will happen? Let's try to do a fancy indexing. So here, if you apply fancy indexing, so last time it was only 1D array, so that is why you have to pass only one list or one array. So here it will be 2 dimension, means row wise and column wise. So we will be having 2 lists. So for example, if I want to get this value from here, actually, so I have to put actually I did a mistake, because all elements are same, but again I can show you guys. So if you put 1 here, okay, I think this is not the right example. Okay, so rather I think I should create something different, so then it will be easier to understand. So b equals to a dot np dot arrange. Let's make it 12 and reshape it to 4-3. Okay, so now it is perfectly become a 2D array. Okay, so now suppose I want this 3. Okay, so 3 means it is 0th position, 1th position from the row wise. So this is 1, and from the column wise it is 0th position, so it will be 1 0. Okay, see, I will get the 3. See, I get 3. Now if I want 3 and 7 together, so 7 is actually 0 1 2 second position in the row wise. Okay, and second position row wise, and column wise 0 1, so it will be here. So for every dimension the list count will be increased. If you are going to deal with one dimensional array, so for fancy indexing there will be only one list, and if you are going to deal with 2 dimensional array, there will be 2 lists for your fancy indexing. See, if I run this thing, I will get 3 and 7. See, I get 3 and 7. For example, see, if I want 11, so 11 is 0 1 2 3, it will be in 3 here row wise, and column wise also it is in the 3. Okay, no, sorry, column wise it is 0 0 1 2, it will be in 2, right? So it will be 11 also will be printed. Okay, I actually put 2.3. See, I got this thing. So this is very useful, guys. So you guys will able to understand what is happening here, but the thing is that if you don't practice, you will definitely forget. Okay, so what I'll do, I will quickly create this tutorial here. Actually, cut, let me run this thing. Okay, so this is for 2-dimensional array. So insert picture from file. Okay, so last example will be with 3-dimensional array. So this is also going to be similar. So let me just create okay, so let's create example 3 here, example 3. Okay, and it should be C. So np.arrange, same thing. So let's I'm just thinking how many I want, how many elements I want. So I want let's say 12. So it should be like how many elements? 2 into 3, 2 into 3, 2 to 3. It should be fine. So it should be like this, and then reshape. So in reshape, let me just create 2. The first dimension means how many it is going to be 3-dimensional array. So 3-dimensional array means every element will be 3-dimensional array will be 2-dimensional array. So first dimension there will be 2-dimensional array. So how many 2-dimensional array? It will be 2-dimensional array. Within the 2-dimensional array, how many 1-dimensional arrays are there? Row 1, column wise. So let me put it like 3 row, 2 column. So altogether it is 12 now. Okay, so see I got 3-dimensional array. So now the same thing, so for 1-dimensional array we have to pass only 1 list of integers. For 2-dimensional array 2 list of integer, and here the dimension is 3. You have to pass for every dimension 1 integer. Okay, so for example I want this 4. So first of all, 4 is in which dimension? So it is in the 0th. Like how many means 3-dimensional array means how many 2-dimension array? The first dimension. So it is in the first dimension, means the 0, right? 0. In the second, it is like in row wise which dimension? It is 0, 1, 2, and in column wise it is in which dimension? It is in the 0. See, if I run this thing, I will get 4 back. See, I got 4 back. So let me just add this thing. See, then it will be easier to understand. Okay, so now if I want 9 as well. Okay, so 9 means 0, 1. So 9 will be here 1. Okay, 9 means 1 here, and here 0, 1 means this is 0, this is 1. So 9 will be here 1, and in column wise also 9 is in the 1 dimension. So it will be 1. So now it will be going to print 4 and 9 together, right? So let's say I want this 5. Okay, so 5 is in the 0th dimension for this thing, means 0 and 1 position wise. Okay, so this will be 0. Okay, then 5 is actually in the row wise 0, 1, 2, 2 means it will be here 2, and 5 is in the column wise in the first dimension, 0 and first index. So it will be in 1th position. So now it is going to print 5 as well. See, 5. So this is how it is, guys. So you have to get the index for the first dimension, then the row wise, then the column wise. You have to get all the index. So that is why it is going to work. So what I'll do now, let me just try to put this thing together, because this is a bit complex. So I will try to put this thing there. Okay, so let me put this thing here. So this is done, guys. So as I told you, so you have to remember few basic things, or else you'll forget. For example, every dimension in a 3-dimensional array will be a 2-dimensional array. So whenever is the dimension, the every element will be the n-1 dimension. This is the basic thing. If you understand this thing, then all the operation will be easy for you. This is a basic building block of all the operations. So don't worry, guys, I'm going to share this notepad file as well, so you'll be able to understand as well in the future whenever you are going to watch this video, and after that if you want to do some sort of practice. But I will highly recommend you guys to do your own practice by your own hand, or else you will definitely forget these things, because these things are very minute, very fundamental things. But if you are not clear about this concept, then in the future you will be able to definitely face some difficulties while building your machine learning or data science algorithm. Okay, so that's it, guys. I hope you guys enjoying the series. Please let me know some sort of feedback. If you want some improvements are required, please also share your feedback. We always love to improve our qualities as well. And in between, if you have any like question or doubt, you can definitely ask me for clarification. I will try to help as soon as possible. And those are watching our channel for the first time, guys, please subscribe to our channel, hit the like button, hit the bell icon, so you should not miss any notification from the next time. And last but not least, thank you very much for all the Udemy students for purchasing this course. It is actually helping me a lot, and same thing is applicable for all of you guys for Udemy actually. So if there is any problem to understand any topic or any section, or if you have any clarification, if you want me to include some other use cases in this tutorial, please feel free to reach out to me via Udemy. I will actually always online over Udemy as well, so we'll try to answer all of your queries as soon as possible. So that's it, guys. Once again, have a nice day. We'll see you in the next video very soon. Till then, take care, goodbye, and happy learning.